right, good morning. Today is April 21st. Welcome to Geometry. A few class rules: make sure to be respectful of others. Use the annotation features when asked. If you have a question, make sure to raise your hand or just let us know. Do your best. A few tips: make sure to have a pencil and paper. That way you can take notes. If possible, find some quiet space. Ask questions, and then attend office hours. So if you don't understand something during class time, you can always attend office hours on Wednesdays and Fridays from 2 to 3 p.m. You don't have to stay the whole time. You can even come for a few minutes, just ask your question. But that's time for us to provide more tutoring or more help, okay? All right, so let's do a quick stress check. So in the chat box, do you know how to use the chat box? Because if you do, you can type in your response to this. So how are you feeling from a 0 to 10? A 0 means you're doing great, you're in a good space, you can focus. A 10 means that you cannot manage your emotions right now. So go ahead and respond. Okay. Now that we're done with our stress check, let's go ahead and look at our objectives for today, Tuesday, April 21st. So we're going to review the 3 trigonometric functions. Sorry, let me make sure. No, sorry. So my objectives for this were, I completely forgot to update them. So we will be reviewing the trigonometric functions briefly, but our focus for today will actually be a bit different than what's listed on here. Today, what we're going to focus on is the finding the parts of a circle. So what are the different parts that are the different parts of a circle? So let's go ahead and look at our do now for today. So number 1, hopefully you got a chance to do this, but I don't think you've submitted it just yet. So let's go ahead and review our do now. So for number 1, what transformation is demonstrated by the figure? So if you look at these 2 images, this is something that we had covered in class about maybe a month ago. So there's translation, reflection, dilation, and rotation. So based on the figures that we have in number 1, what do you think the transformation is? So let's look at question number 2. So if the perimeter is 47, find x. So perimeter is when you add up all the sides. So if we're looking at our perimeter, we need to add up all the sides. But we know what the perimeter is. Our point is to just find x. So we would do 2x plus 6. And we would add that to 3x plus 8. And then our last side, which is x plus 3. And that is equal to 47. So when we have a problem like this looks like a lot, but we have to find our common like terms. We have to combine them. So let's look at the ones that have x. And I'm going to put the sign in front of it just to help me. So when I combine those 3, I have 2x plus 3x plus x. So I know that 2x plus 3x is 5x plus x, that's 6x. And then I can combine 6 plus 8 plus 3. And if I add those, I know that that is 17. And now we solve for x. We continue to solve for x. So I like to do this line to separate my 2 sides. That helps me, but I'm trying to get rid of this positive 17. So I do the opposite. I subtract 17 from each side because whatever I do to one side, I do to the other side. That leaves me with 6x is equal to 30. And then to get x by itself, because that's multiplication, I divide. Whatever I do to one side, I have to do to the other side. And I know that x is equal to 30 divided by 6 is 5. So I look at my answers and then I make sure to find the correct answer. Sometimes the answers will be shuffled, so you have to make sure that when you get an answer that you find the correct one. So let's look at the problem of the day. So for today's problem, I'm going to try to do a word problem at the beginning. of each lesson that has to do with our lesson, and at the end, hopefully we'll get to solve it. And if we don't get to solve it during that lesson, we'll hopefully be able to solve it by the end of the week. It just depends on the type of problem and what's required to solve it. So when reading this problem, it says, the radius of a semicircle flower garden is 6 feet. What is the cost of fencing the straight portion of the garden if each foot costs $2? So if you remember in class, we did 3 reads. For a 3 read, we first focus on what is the problem about. So in this case, what is the problem about? So I'm gonna go ahead and do a second read. So for my second read, it's the radius of a semicircle flower garden is 6 feet. What is the cost of fencing the straight portion of the garden if each foot costs $2? Do you remember what we focus on for the second read? Second read, since we focused only on what is the math that they give us, we looked at 6 feet and we looked at $2. And then our third portion would be, once we do a third read, so again, the radius of a semicircle flower garden is 6 feet. What is the cost of fencing the straight portion of the garden if each foot costs $2? Now we ask what's the math question? In this case, they give us a math question, so we need to figure out how to solve it. Our math question is, what is the cost of fencing the straight portion of the garden if each foot costs $2? So when I look at this garden, let me see if I can go ahead and highlight it. The straight portion of the garden would be this part, right? That is a straight portion of the garden. So we're trying to figure out how much would it cost us to put a fence there. So before we even look at that, the first thing that we're gonna do is we're gonna look at the different parts of a circle. So a circle is a closed curve formed by a set of points on a plane that are equidistant from its center. So notice on the circle, there are a bunch of points and they're all the same distance from the center. So this is my center of the circle, right where my arrow is, let's see if you can see. If my center is right around here, right? All these points are about the same distance or are the same distance from the center. And remember, you can always ask me to stop or to go a little bit slower if you need me to. So the midpoint of a circle is called the center. So on a circle, also since we're focusing on just the parts of the circle for today, that is the center. Now, let me go ahead and move this out of my way. Give me 1 second while I move this taskbar. All right, so the length of the line from the center to any point on its edge is called the radius. So notice that this circle, there's this line going from the center of the circle to an edge, and it doesn't have to be here. The line, that can be done anywhere. So if I have my, there we go. This, let's see if it writes, is also a radius. Any line that is formed from the center to the edge of the circle is called a radius. And it would be a straight line. I know mine's a little bit crooked, but make sure it's straight line. That is your radius. Now the length of the line that touches 2 points on the edge and goes through the center is called the diameter. So the diameter breaks up the circle in half. So notice that this line goes all the way through and it touches the center. So the radius is only half of that. Let me go ahead and erase my drawings. But my diameter is this whole line that goes through the center. So that is called a diameter. It doesn't have to be going up and down. It doesn't have to be a vertical line. It can be a horizontal line. It can be diagonal, but it cuts my circle in half. That is a diameter, and it goes through the center. So if you look at this, we have little dots. So the radius is half of the diameter. So in order to make a diameter, you need 2 radius, right there. That makes your diameter. So your radius is half of the diameter. Now, if you have a line that connects one point on the edge of the circle with another point on the circle, that's called a chord. But notice that this chord does not go through the center. It goes on the side, it's off to the side, but it does not go through the center. So it cannot be considered a diameter. It's not a radius. All right. So next we have the distance around the circle. So the distance around the circle, and let's see if my little animation worked. There we go. Notice that the car is going around the circle. So the distance around the circle is called the circumference. So let's look at that one more time. So that distance around the circle is called the circumference.
I can't see the word.
Oh, you can't see. Oh, it's not showing the word at the bottom.
It's like it's only see a little bit because I have right here.
Okay, so let me write it because I think your taskbar is probably covering it. Let me go ahead and let me know if this helps. It's glitchy. Hold on.
I know your voice glitches a little bit sometimes.
Oh, that does too? Okay, thank you for letting me know. I think my connection isn't the greatest and I've tried 3 different ones. All right, so circumference, is that better? Can you see it?
Okay. Yeah, circumference.
And that is the distance around the circle. Next, you have a segment of a circle, and that's called an arc. Can you see it? There we go. And that's this part. Not only this part, it can be over here. It can be cut up on this side as well. That's your arc. Notice it can be any segment of your circle. All right, so let's look at the different parts, and I want you to help me label these parts. So when we're looking at these different parts of the circle, what is that called?
The center.
Good. What about this one?
The radiation.
The radius. So good, but really good try. So you knew exactly which one. It's just radius. Okay. Next one, this one that splits it in half. What is that called?
The dimension.
Good. Diameter.
The diameter.
Good, really good. Diameter. Next one, what about this one? You need help with that one?
Yep.
Okay, so this one is the chord.
The chord.
Oh, what is it? Oh, I'm clicking backwards. Oops. Not this one. Oh, I already showed it.
Circumference.
Circumference, good. And not least?
The arc. The arc.
Good, really good. All right, so now looking at the problem, so let's go back to our original problem, which was the radius of a semicircle flower garden is 6 feet. What is the cost of fencing the straight portion of the garden if each foot costs $2? So we know that the radius is only a portion of that, right? Because if we wanted to go all the way through, what is that called?
The diameter.
Good, really good, diameter. But we only know the radius. How long is this portion of our garden?
3 feet.
How many feet?
3.
Well, okay, so if this is the radius, so that it tells us the radius is how long?
6 feet.
6 feet. So we know that our diameter would be how much?
12.
Really good. So our diameter would be 12 feet. Really good. So we know that we need 12 feet in order to make a fence that covers this whole section of our garden. So now that we know that this is now a drawing representation of our garden. You said that all of this would be 12. How do you know it's 12?
We add up.
We add up. Mm-hmm.
We add 6 feet.
Good. So this is another 6. Good, really good. So we have 6 feet, 6 feet, so that made 12 feet. So we know that we need a fence that's 12 feet. So if we know that it is 12 feet, and then each foot costs how much?
$2.
$2. How much would we be paying for our fence?
$14.
So each foot, so if each foot is $2, so that means that 1 foot would be $2.
$4.
If I add another foot, my second foot would cost $2. And I keep doing that 12 times. What would it cost? And if we remember, when we look at the word each, sometimes we can use what operation we can use. Is that addition, subtraction, multiplication, division?
Each. Multiplication.
Multiplication. Because again, if each foot, so 1 foot, $2. My second foot would cost me $2. Third one, and if I have to keep going 12 times, I'm multiplying 12 feet by $2. So what would that equal to?
Maybe at the time 12 times 2, right?
Good.
So 12 times 2. 24.
Good. It would cost a total of $24 to create that fence for your garden. Really good. All right, so our next step. So after class, make sure to complete the do now for today. Okay. Make sure to complete your exit ticket. And then before the next class on Thursday, we have that do now for that class as well. Okay. So try to stay on top of those do now so that way your work doesn't start adding up. But like always, if you have any questions, we are available Wednesdays and Fridays from 2 to 3 p.m. for office hours. And as I mentioned at the beginning of class, you don't have to stay the whole time. You can just come in, ask a question, and then you can leave if you want. Or I can go to more explanation of what you need to do for office hours, okay?